Guys, today we'll start with the Beer's law. This experiment is a very nice experiment. We determine the concentration of unknown compound that has to be color. So it has to be color means this compound we are measuring its concentration has to have the ability to absorb light. This is a condition. So that's a condition for this Beer's law. This is a compound. We are looking for its concentration, molarity, mole per liter, but we are looking for the mole per liter for this. It has to be colored. Can I have a non-colored compound? Can I have its concentration versus Beer's law? The answer is no. H2O has no color. I cannot determine its concentration with the Beer's law because transmittance, absorbance will be 0, transmittance will be 100%. So Beer's law, if you look at this, the transmittance of a light, correct? So if I have this cell here, you'll have a cell here. This is the cell here. And the light will come in, say 100%. And because this compound is colored, it will absorb part of the light and it will go out like say 80%. So the 20% of the light is taken by the compound, by the colored compound, is absorbed. So it is the difference here between 180 is about 20% absorbed by the colored solution or the compound solution, correct? And the transmittance is defined as the log of the intensity of coming out. The light I means light intensity. Light intensity, in this case say 80% out, divided by light intensity in, going in 100% and then going out 80%. This called the transmittance, percentage transmittance. Any compound that has a color will give you this effect. Any compound that has opaque means it transmits the light 100%, it will not absorb, correct? And if you look at this, the absorbance of this compound for this light will be epsilon LC. L is the length of the cell itself. This is L. L is cell, or sometimes called cuvette, Q-U-E-V-E-V-E-V-T-T-E, cuvette. So cell or cuvette without E here. C-U-V-T-T-E, cuvette, that's T. Cell or cuvette. So that's the length of the cell here. That's the what we call the light cell. At the same time, it's really is light path. This is the distance of the light is crossing from the edge of the cell to the edge to the other edge of the cell, correct? And E epsilon is constant, and this constant depends on the material, on the compound itself, correct? This is depends on the type of the glass, type of the compound itself, type of the whole system itself. So this is the constant here. And C, which is really we are interested in, that's the concentration. So with this in mind here, we can determine the concentration of unknown compound. Now, with the graph we are looking at today, you can use the Excel at home, but at least you have to gather the data here. So So everybody has this. Everybody has this. So what's happened is we are collecting. We are making a compound. I think we are taking nickel nitrate, nickel 2 nitrate, and this is hexahydrate. 6H2O means hexahydrate. Nickel 2 nitrate, because nickel has more than one charge. Nickel 2 nitrate hexahydrate. So we'll take this one here. We'll make a certain concentration. That will be our stock solution. We'll do a stock solution. We'll make stock solution out of this. Okay, and I think you can count. You can calculate how much you need. I calculate that for you. I think you take about 0.40 grams of this compound here, dissolve it in H2O, in 100 ml of H2O, and then you can work with it. So I'll show you the concentration there in a minute. But you take this. This is it's more greenish color solution, and it has it will be, that's your stock solution. That's the main one. Out of this main one here, we'll make 4 more dilutions. So we'll make what? 4 dilutions using the formula of the dilution law. C1V1 equals C2V2. C1 is the concentrated one, volume of the concentrated one. This is diluted one. This is diluted one. Okay, guys? After doing all this one here, what we will do here, we'll take each one of those test tubes we have, or the solutions, we'll fill the cuvette, and then run it to to record the absorbance. We are recording what? The absorbance. We know the concentration of each, so we need the absorbance. Remember, we are looking for A epsilon L multiplied by C. Okay, so epsilon is the material, the compound, the material you are using, so this is constant. So we are looking at this. So the graph will be looking when you have absorbance here, and this is the concentration, correct? You start taking 0, 0, and you'll see a very nice linear relationship between absorbance and concentration. Here it is. With your Excel, you will get something like this: absorbance versus concentration, and those are the 4 concentrations you have, plus the 0, 0 coordinates. You have to get it from 0, 0 coordinates, correct? And you can get the relationship, whatever is absorbance equal whatever value multiplied by the concentration. So whatever, this is the slope here. Slope here. So here it is. This is the slope multiplied by C. So this is equation here, is a linear equation, and then from there I have this, we will call it calibration curve. What we call it? Calibration curve. We have 4 known concentrations. We use 3, whatever the 4, and the 5th here, the 0. 5 points we have in the graph, all those well-known concentration. We measured their corresponding absorbance, correct? We did this one here, we call this one here is our calibration curve. This is very important. That's the Pierce law. Calibration curve. Now I can take an unknown. There is an unknown solution here of this nickel, and then measure the absorbance of it. So I'll come here and then I'll say, okay, let's look at unknowns given by the lab supervisor. Give us the unknown. I will go and measure his absorbance, and then from the absorbance, suppose it gave me the absorbance somewhere is in this one, correct? I go all the way on the line, go back here. This is my concentration of my unknown. Are you following me? That's the whole thing. So we are looking for the concentration of unknown solution of a color solution called nickel 2 nitrate hexahydrate. It has 6H2O. And then we're doing this, we have to use the spec 20 to have the calibration curve with the 4 dilutions beside the 0, 0 coordinate, correct? And then I run, after I'm running everything here, I will run the absorbance of this unknown, plug it into this curve, and then I can determine the concentration of this unknown. That's the whole experiment. Okay, guys? That's the whole experiment. Now, can I take this one out? I want to go for the procedure step by step. Correct? That's the whole thing. So, let's take this one here out, and let's look at the procedure here. Let's look at the procedure, guys. So, first of all, you need to calculate your 0.4 grams. Here it is. The calculation is done for you here. So we are looking at a 0.4. We are producing not 4 gram, but 0.4 molar solution of nickel to nitrate hexahydrate. So we'll be using this one here. We'll be using this. We'll be using this. All of us will be using. Then I can compare. So we will prepare 0.4 solution. That's, we call it our stock solution. Stock solution. And this is the most concentrated one. Most concentrated solution. And here's the calculation how much you need. You need 7.3 grams of this nickel 2 nitrate. I give you all the calculation is made for you. And I think I made the calculation, this one here. You make 7.3 grams. You dissolve it in 100 mL. So this solution is dissolved in 100 mL. 0.10 liter means in 100 mL. So in 100 mL means you weigh this one here. You will have your flask here, volumetric flask. By now you know the volumetric flask. Volumetric flask has a line here, marker, which really tells you this marker is 100 ml. So you put 7.3 grams here at the bottom. Don't fill it up to 100, no. You just add few H2O, little bit at the time, to make sure that everything is dissolved. Then when everything is dissolved, then you can fill it up to 100. You keep checking it. If you have a lid to cover this, even lid here to cover it, so you can back and forth shaking this volumetric flask to make sure that everything of this nickel is dissolved, correct? And to fill it up to 100 ml mark of the volumetric flask. We'll not do this. This one will not do it. We'll do just the nickel nitrate. So that's the stock solution preparation. Okay, guys. Everybody has this. Everybody has this. Let me take it out.